In this video, we'll be looking into the important topics of third module, that is basics of learning theory, similarity-based learning, and regression analysis. So if you have not watched my previous video, I have covered all the important questions module-wise. So as an extension to that, here I'll be discussing the answers of third module. So first we have the theory topic, what is the learning theory? And so let's start with this. So learning theory is a process of acquiring knowledge and expertise through study, experience, or being taught. So computers, this was a particular definition of learning theory. Computers can solve only well-posed problems as these have well-defined specifications and have the following components inherent in it. So the particular problem should comprise of all these, that is class of learning tasks T, measure of performance P, source of experience E, and capital X as the input space, where small x is one instance or one input and capital Y as the output space. So here, considering D to be the input data set, I have the solution, the question, the input as well as the output for that particular instance for n inputs. So we have the unknown target function here, that is x derives y. Okay, so we need to pick a function g such that x derives y to approximate the hypothesis f. So all the possible formulae compute the hypothesis space. So that's what a hypothesis space refers to. So looking at this diagram, we have the training samples here and then the candidate formulae. So these come under the hypothesis space. So with the help of learning algorithms, we generate the hypothesis, that is g of x. So if this is different from the ideal target hypothesis, then it results to error. So that's what this diagram represents, this flow diagram represents. Next we have the training samples and the target function are dependent on the given problem. That is, the learning algorithm and hypothesis set are independent of given problem. So we'll look into the learning here. A definition of learning model would be comprising of hypothesis set as well as the learning algorithm. So looking at the learning types, so in order to acquire the knowledge, we can either acquire the knowledge by memorization or examples or critical thinking or self-learning. There are many others also. Do refer the PDF. I've uploaded it. Next we have design of learning system. So firstly, in order to design the learning system, we need to choose the training component firstly, and then the training function, and then representation of training function, and then later approximation is done to the training function. So this was about learning theory. Now we'll dive into the specific topic, that is concept learning. So learning strategy of acquiring abstract knowledge or inferring a general concept or deriving a category from the given training samples is what called as a concept learning. So it is a process of abstraction and generalization from the data. So it helps to classify the object having common relevant features. So in order to compare, contrast with the association of positive and negative instances in training data and to classify an object, we make use of concept learning. So concept learning basically requires three things. So the first one is input, that is the training data set, capital T, and then the output, the target function, whatever you require. And then the test, here new instances to test the learned model. So here we make use of small t. So this was about concept learning. Next we have hypothesis. So the hypothesis is given. So search through the hypothesis space in order to match the target concept. So that is about hypothesis. Then we have hypothesis space. So set of all possible hypotheses that could be chosen to explain the data set. This includes a range of potential models that could describe underlying patterns in the data. Then we have the version space. Version space is subset of hypothesis space that is consistent with all observed training instances. So once you obtain the output, I'll explain you in finders and candidate elimination, we need to derive the version space. Okay, so for example, color could have black, blue, white, red, yellow. These are the version spaces of color. Then we'll be using these terminologies. Question mark. If you see question mark, it denotes that attribute can hold any value. And if there is 5 here, it denotes that the attribute can't take any value. So this was about question mark and 5. Now let's look into the finders algorithm. So input, the positive instances in the training data set are considered as input, and then we need to generate a hypothesis H. So firstly we initialize H to be the most specific hypothesis, that is we fill everything by 5, that is it can't take any value initially. Then we generalize initial hypothesis for the first instance. So from the given table, consider the first instance and apply it to this H value, the most specific hypothesis. Then from the subsequent instances, if it is positive instance, then we check for the attribute value with H. So if it is positive instance provided here in the table, then we check, that is if attribute value is same, then we need not change it. If attribute value is different, then wherever the attribute value is changing, replace it with question mark, that is it can hold any value in H. Then if there are negative instances, then just ignore it, copy the previous H to the next H as it is. So this was about finders algorithm. And next we have the candidate elimination. So in this, set of instances in the training data set, and then output is the hypothesis G and S. Here previously in find S we had only H, whereas here we have G and S. G is the most G is the most general hypothesis and S is the most specific hypothesis. So initialize G to maximally general hypothesis and initialize S to the maximally specific hypothesis firstly, and then we generate initial hypothesis for the first instance, like how we have done there. And we start comparing each and every instance. If the instance is positive, check for the attribute attribute value of positive instance and S. If the attribute value of positive instance and S are same, then no change. If it is different, then fill it with question mark. It was same as find S. Now we prone to exclude all inconsistent hypothesis in G with plus instance. So this I'll explain you while solving the problem. Then if we have negative instance, if it is positive instance, then update the value of S, and if it is negative instance, then update the value of G. So specialize G to exclude the negative instances, add G to all minimal specializations to exclude negative instances for examples, and be consistent with S. So if attribute value of S and negative instance are different, then fill attribute value with S value. If they are same, then no need to update, you can fill it with question mark. And then now remove from S all inconsistent hypothesis with negative instances. So we'll look into the problems now. We'll look into the solving the problems now. So the first one we have here is they have given the data set, the training data set here, which comprises of attributes like CGPA, interactiveness, practical knowledge, skills, communication, logical thinking, interest, and job offer. Job offer is a final output. Okay, this is positive instance here. This is also positive instance. This is negative instance. And here we have positive instance. Okay, so we need to solve this. Firstly, solve using find S algorithm. So for solving find S algorithm, firstly we'll take H0, that is initial hypothesis, most specific hypothesis, as 5. Okay, fill it with 5, that is it can take any value. Okay, H0, fill it with 5. Here how many instances we have? 1, 2, 3, 4, 5, 6. 6 attributes are there, right? So fill it with 6 5s. Okay, next I will start considering each instance. Okay, so this one is I1. I'll start with I1. So I'll write I1. I'll specify the instances Y, E, G, F, and Y. So now that I've specified here, and this is positive instance, right? So whenever I have positive instance, check for each attribute value with H. So if the values are same, then no change. If the values are different, then replace it with question mark. So here if I compare it with H0, I'll write the value here as S. Okay, so it would be here greater than equal to 9 is there, here 5 is there, here also Y, here also 5. So I'll get the same I1 value as it is. Okay, because 5 says that it attribute can't take any value, but then when we are comparing it with the first instance, it can take these values. Like we'll update it, right? So 9, Y, E, G, F, and Y. So I'm done of finding the first H1 or S1 value. Now let's move on to the I2. I'll consider the second instance. So that is greater than equal to 9, Y, G, G, F, and Y. This is also positive instance. So I'll compare this with the previous H value or S value. Here I've taken it as S. So compare I2 and S1. So I get S2 here by comparing I2 and S2. If the values are same here, write it as it is. And if there's any difference, then put a question mark there. So here greater than equal to 9, greater than equal to 9, it's the same. Y same. Here there's a variation, right, between these two. So I replace it with question mark. Okay. Next, GG same. I have F here and I have Y here. So I'm done with finding the S2. Now I'll consider the third instance. I'll write greater than equal to 9, N, G, G, F, and N. Here I have negative instance. So whenever I have negative instance, for negative instance, ignore it, copy the previous H as it is. So they have said for negative instance, ignore it, copy the previous H as it is. So here I need not perform anything. For S3 value, I'll copy whatever S2 is there as it is. Okay. Greater than equal to 9, Y, question mark, G, F, and Y. Next I have I4. I'll write I4 here. I4 comprises of greater than equal to 9, Y, G, G, S, and N. So this has positive instance. So I need to compare it with the previous H value, S3 value. Okay. So to get the updated S4, I can write these two are same. So it will be the same. Then here Y, so same. Question mark and G. So I'll put question mark itself because question mark states that it can take any value. So not only G, it can take other values also. That's what the question mark refers. So whenever we have question mark and G comparison, put it question mark only. Then G and G is there, put G as it is. F and S, there's a change in value, so put a question mark. Y and N, there's a change in value, put a question mark. So here we have reduced the final H value, final hypothesis value. So here if you see, we have neglected the negative instances and included all positive instances. So this was about fineness algorithm. Looking at the drawback or the limitations of fineness algorithm, that is, it tries to find hypothesis that is consistent with only positive values. Only positive instances, if they are present, then only the hypothesis would be generated. But then if there are negative instances, we neglect it. Now we'll be looking into the candidate elimination. Candidate elimination for the given value here. They have specified the value here, right? All the data set is being specified here. In candidate elimination, we make use of S and G. S hypothesis and G hypothesis. S hypothesis is for the positive value and G hypothesis is when we have negative value. So firstly, we'll start with S naught. S naught being the most specific hypothesis, fill it with 5. So here 6, 1, 2, 3, 4, 5, 6. 6 instances are there, right? 6 values are there. Fill it with 6 5s. 1, 2, 3, 4, 5, 6. Now firstly, I'll take the I1. I'll write the I1, that is greater than or equal to 9, Y, E, G, F and Y. Now this has positive instance, so I need to compare I1 and S0. When I compare S0 and I1, I get S1. So update the S1 value. Here it will be the same. Next, I'll consider I2 now. So writing for I2, I have greater than or equal to 9, and then here I have Y, and then here I have G, F and Y. So as you can see, this also has positive instance, but then there's a difference. Like when you compare S1 and I2, here there's a difference. Right. E and G. So wherever there's a difference in value, put a question mark there. So greater than or equal to 9, Y, question mark, G, F and Y. Okay. Next I'll consider I3. So writing I3 values, greater than or equal to 9, N, G, F and N. Here I have negative instance. So whenever I have negative instance, I need to update the G value, right? But G value, I'll start it from the downside later. Now as of now, I'll keep this on hold. And S3 value would be the same, whatever is there here in S2. So greater than or equal to 9, yes, question mark, G, F and Y. Okay. Then I have I4. I'll write I4. I4 values are greater than or equal to 9, Y, G, S and N. So this has positive instance. So comparing S3 and I4, I get S4 as greater than or equal to 9. These are same. Here also Y same. Question mark and G, I'll put question mark. G, F and S, I'll put a question mark here. Y and N, again a question mark. So I have obtained the final value of S hypothesis. Okay. This was one side of S. Now from this side, I need to write for G. Okay. So initially G naught value would be question mark. Okay. 1, 2, 3, 4, 5 and 6 question marks because 6 values are there here, right? Next, for I1 instance, I got S1, right? Because it had positive instance. So here the values would be the same, question mark only for I1. For I2 also it would be the same only. But for I3, as it has negative instance, I need to update the value of I3 with G3, right? So here I can write, in order to update the G3 value, here I have negative instance, right? This one. So I'll compare this and S2. So if the values are same, then write it. Okay. So here greater than 9, I'll write only the first value and then rest all I'll put question mark. Okay. Next, here I have Y and N, right? So I'll put Y. Okay. Question mark, Y, question mark, and question mark. Next, I have question mark and G here. So it is question mark as it is. And then G here. So you need not write it. FF need not write it. But then here I have Y and here N. So I'll write Y. Okay. All these are question mark. Here I'll write Y. 1, 2, 3, 4, 5 and Y here. So this is for G3 value which I have obtained. Next, I'll look into G4. So G4 was here, it was positive instance. So the updated here, whatever G3 was there, I need to update it. But then I'll write the first one as it is, greater than or equal to 9. Question mark. But then out of these two, if you compare it with S4, then here YY is there, right? So, here question mark is there, here Y is there. So if you compare also, you'll get question mark only. But then here YY is there. So I can write question mark, Y, question mark. So this was for G4. So now that I have obtained S4 and G4, now I'll write the version space. So version space can be written by considering these two. Okay. So firstly, I can write greater than or equal to 9. Yes, question mark. This is one hypothesis which I can obtain from this by comparing this. Then another one which I could obtain is greater than equal to 9, question mark, the good will be as it is, and then again question mark. Here question mark, here I'll consider yes and good, these two I'll consider with this. So question mark, yes, question mark, good, question mark. So in order to get this, I've compared this one and this one. So next, in order to get this, I've compared this one and this one. Then to get this, I've compared this and this. And I've also compared this with this. So this was for candidate elimination. So if you have an option between finders and candidate elimination, I would say go with finders because it's pretty simple and you can solve it very easily. Next, we have the next topic, that is, we have another question here for finders and candidate elimination. So writing the finders first. So firstly, I'll take H0. Most specific hypothesis is filled with 5 values. Here I have 1, 2, 3, 4, 5, 6. 6 different values, right? So I'll fill 5 values. Then I'll take the first instance I1. I'll write it sunny, warm, normal, strong, warm, and same. Okay, this has positive instance. So I'll compare it with H0. So I'll get the updated H0 or S1, which I can write it as SWN, SWS. Okay, next I'll write I2. So I2 values are SWH, SWS. So this again has positive instance. So I need to compare I2 with S1 in order to get S2. So when I compare these two, I get SS, it's the same, WW, it's the same, N and H is there. So wherever the values are being changed, I'll put a question mark there and then SWS as it is. Next I have I3. So I'll write the I3 value, that is RCHSWC. So this has negative instance. So whenever negative instance is encountered, do nothing, but then write the S2 value as it is. So I'll write SW question mark SWS. Next I have I4. So I4 value, I'll write SWH SCC. So here this has positive instance. So whenever positive instance is encountered, compare I4 with S3 in order to get the S4. So here SS the same, WW the same, here question mark and H is there. So I'll put question mark. Here SS, so S, W and C values are changed to put a question mark. Here also S and C is there, so put a question mark. So here I have obtained the final hypothesis. This one was for finders algorithm. Now I'll write for candidate elimination. So I should include two hypotheses, S and G. S would be updated whenever I have positive value, G would be updated whenever I have negative value. So starting from the S, so S0 I took it as 5. Most specific hypothesis, here 6 values are there, right? 6 question marks. Then I'll start with the I1 value. So I1 value I'll write SWN SWS. This has positive instance, so update S1. S1 would be updated, so it will be SWN SWS. So now in the previous question I had written it in this form, right, where I had updated S on one side and then G on one side. Instead you can do it directly also. You can write here only. You can get G1 as, see, S0 were these values. G0 would be question mark, question mark, question mark, question mark, question mark, question mark. S0 would be most specific and G0 or G would be the most general. General is question mark, specific is 5. So here G value would be question mark as it is. S1 G1 I have obtained. Next I'll take I2. I2 I'll write SWH SWS. Okay, again positive. So I need to update S2 value by comparing it with S1. So it will be S and S is there here, W and W, N and H is there, N is there, H is there. So I'll put a question mark and then S, W, S are same. Now for G2 value, as it is positive instance, no changes are being taken place. So I'll write whatever is there in G1, I'll write it as it is. Now I'll consider I3. So let me write the I3, RCH SWC. So this was for I3. Now I3 has negative instance. So whenever I3 have negative instance, I need to write S3 as it is. Whatever is there in S2, write it as it is firstly. SW question mark SWS. I'm done with this. Now next, writing the G4 value, G3 value. Negative instance means G3 value should be changed. Writing the G3 value, here I have question mark. Compare I3 with S2. Okay. So here I have S and here I have R. So put whatever is there in S. Okay. Then followed by question marks. Firstly, 1, 2, 3, 4, 5, 6. So you need to compare only one instances and write it in this form. Okay. Like how I've done in previous question also. So I compared S and R. So by having r here, I have got negative. In order to convert it into positive, I'll substitute r with s. So that's what I've done here. S question mark, and followed by 5 question marks. Then I have w here and I have c here. So again put w value here. That is, first one would be question mark and then w followed by 4 question marks. Next I have question mark and h here, so it is question mark only. Next I have s and s, so s only. W and w, so w only. And s and c is there here. So s is there here, c is there here. So I need to put s. Okay, so s is at the last. So 5 question marks followed by 1 s. Okay, I hope you have understood this step. Even in the previous question, I hope you have understood this step. I'm done with I3. Now I have I4. I'll update the I4 value, that is swh scc. This has positive instance, so I need to update the S4 value. So compare I4 and S3. So when I compare S and S, I'll put S itself, W and W, W, question mark and H, question mark, S and S, S itself, W and C, question mark, and S and C, question mark again. Now writing the G4 value, here I have Sunny, I'll write it as it is. So S, question mark, question mark, question mark, question mark, question mark, followed by that whatever is there in warm, I'll write it as it is, 6, and then this S also I'll write as it is. Now that I've obtained the S4 and G4 values, now I need to write the version space, right? So version space by comparing S and G. So writing the version space, S4 would be SW question mark S question mark, and then G4 would be S question mark and then W question mark. Here if I write, see if you check here, I have S here, but then for positive instance I need to get C, right? So I need not consider this. I can put question mark here. Okay, so I can write question mark W question mark question mark question mark question mark. So writing the final value here, I get, okay, these two, and along with that I get S question mark S question mark, and then I have SW, then I have question mark W question mark S question mark. So I have obtained these values by comparing these. Okay, so next see SS S W question mark, and then here question mark S and question mark, I have written S and then question mark as it is. Next comparing these two with this, so SW question marks, and then this with this, so question mark W S question mark W. So this was about candidate elimination. I would suggest. Next we have the similarity based learning. So in similarity based learning, it is also called as instance based learning. So we make use of similarity measures to locate the nearest neighbor and classify a test instance which works in contrast to the other learning mechanisms. So here similarity based classification problems formulate features of test instance and training instances in Euclidean space to learn the similarity or dissimilarity between the instances. Then we have the first one is KNN algorithm. We'll be considering KNN algorithm. So input would be the training data set T, and then distance metric would be considered as small d, and then test instance as small t. The number of nearest neighbors as k. So output is we need to predict its class, whatever the test instance is given. We need to predict a output for it, or a class for it, or a category for it. So prediction is for every instance small I in the T, we need to continue computing this, that is the Euclidean distance. So in Euclidean distance, x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square, where x1, y1, z1 would be the test instances. After finding the distance value, we need to sort it in ascending order and then find the nearest training data instances to the training instances, depending on the k value. K value would be specified in the question. After that, we need to perform majority voting or find the mean. So depending on this, we can identify the class or a category for the given value. So looking at the performance of k and n depends on the neighbors, the distance metrics, and the decision rule. So if k value is small, it could lead to overfitting. That is, it will make the class or category or the prediction as less stable. And then if k value is large, then it results in irrelevant information. So it best suits for lower dimensional data. Okay. Now we'll solve a question related to k and n. So this is the training data set which they have provided. Okay. So here we have CGPA, assessment, project submitted, and result. So my first step would be, and I have not written the given value. So here given, this would be specified in the question. The test instance values are 6.1, 40, 5. 6.1 is for the CGPA, assessment is 40, and project submitted is 5. Okay. And the classes which I have to decide are P or F, pass or fail. And then here the K value is also specified. We take it as 3. Okay. Now our first step is to find the Euclidean distance, right? In order to find the Euclidean distance, we have the formula, that is let's consider this as x, this is y, and this is z. So x would be xi minus, we'll consider this one as 6.1, okay, 6.1 whole square plus assessment, we'll consider yi minus 40 whole square plus project submitted, that is zi minus 5 whole square. So we'll substitute this value in the calc. So under root I can write x minus 6.1 whole square plus bracket open y minus 40 whole square plus zi value. So that would be, I'll open the bracket, I'll write z is not there here, so I'll consider m minus 5 whole square. Now I'll press calcs. Okay, firstly, in order to solve this question using calc, firstly I'll write the equation, that is x minus 6.1 whole square plus y minus 40. So y minus 40 whole square plus z, I'll consider m here, minus 5 whole square, and then I'll press to calculate it. First I'll take the input value as I'll write the values here, 1 2 3 4 5 6 7 8. So firstly here the input is 9.2, so I'll write 9.2 for x, and for y I have 85, and then for z I have 8. So when I substitute all three, I get 45.2063. 45.2063 is the distance for this first serial number values. Okay, so I'll write here 45.2063. Next I have 8 here, I have 80 here, and then I have 7 here. I get 40.0950. Here I have written, here I have calculated all the distances and I have written it here. My next step was to sort the distance in ascending order and find k nearest training data instances to the training instances. So instead of writing this again in ascending order, here the k value they have said is 3, right? So from this distances I need to select k is equal to 3. I need to select 3 instances which has the least d value. Okay, so the first one would be 7, which has 2 here, and then the second one would be 4, which has 5, and then the third one would be 10. Okay, so I'll write those here. Here k value was 3, so 7 4 5, I can write it as 2.022375, and then here for 4 I have 5, and for 5 I have 10.05783. So I have written this. I'm done with the second step and the third step. My last step is to compare. Okay, for 7th serial number, this row the result was fail, right? So for 7 the result was fail. Okay, for 4 it was fail, and for 5 it was fail, and for 5 also it was fail. So when I take the majority voting, so even for the test instance also it would be fail itself. So for test instance, the class which I have obtained is F. So this was about the KNN algorithm. Now let's move on to the next algorithm, that is weighted KNN. So weighted KNN is a updated version of KNN. So here the selected KNN can be assigned a uniform weight. So which means that all instances in the neighborhood are equally weighed or could be assigned inverse of their distance. So in second case, close neighbor of query point will have greater influence than that of neighbors which are far away. So looking at the algorithm, this is similar to the previous one. We take a training data set T, distance metric D, weighing function W of T, this is new, and then the test instance small t, number of nearest neighbors is K. Output is to predict the class or category. And then firstly we calculate the Euclidean distance and then sort it in ascending order and then predict the class of test instance by weighing voting technique W of I. So under this, firstly we compute inverse of each distance and then find sum of inverse and then divide weight by the sum. After that we get the weight values, right? That we compare and get the final output. So that was about the algorithm part. Now let's solve the problem here. So let's consider this the same example. So for this also, first step, let me write the given instances. So given t value test instance they have given us 6.1, 40. So let me write the given test instance values, that is 7.6, 60, 80. These are given, and the k value is assumed, k value is taken as 3. So these are specified in the question. Okay, my first step would be to calculate the Euclidean distance. In order to calculate the Euclidean distance, I'll make use of calci, like how I've done in the previous question. So which would be, I'll write the equation here, xi minus 7.6 whole square plus yi minus 60 whole square plus 8 minus zi whole square. So substituting the values of x values, y values and z values, I get serial. I'll compute the table with results. After calculating the d values, I need to find the d inverse value. That's what the algorithm says, right? Compute inverse of each distance of k selected neighbors. So I need not compute inverse for all the values. So I'll select whichever is the smaller one here, right? Okay. So the k value specified is 3. So I need to select 3 smallest distances from here. So the first distance would be, I have 10 here, right? So this would be the first distance, 1. And then this would be the first one. And then I have 12 here. So this would be the second one. And then I have 15 here. This would be the third one. So computing the inverse values for these. So 1 by 15.380, I would get 0.0650. So I'll write the inverse value, that is for 15, 0.0650. For this, it would be 10.826. I would get 0.0924, and for this I would get 12.0565. I get 0.0829. Now that I have found distance inverse of these 3 values, my next step would be to find sum. Okay, so sum of all these. So I get 0.0650 plus 0.0924 plus 0.0829. So when I add these, I get 0.24033. So this is a sum value. So after calculating the sum value, they have told to find the W value. Right, W value is the inverse D divided by the sum. That is, I have considered 4, 5 and 6 here, right? So I'll write the D inverse value first. Here it was 0.00650. Here it was 0.0924. Here it was 0.0829. So calculating the W value, I would get 0.2705, 0.3843 and 0.3451. So now that I've calculated the value, here let's see the result side. Okay, for 4 it is fail, for 5 it is fail, and for 6 it is positive. So by this only we can say that it is fail. But then the last step which they have asked us to add the weights of similar classes. So here F and F, so for F class it would be 0.2705 plus 0.3843, which would be 0.6754 something. Okay, and then for pass it would be 0.3451. So we can see that this value is greater, right? So the test instance is fail. So this was about the weighted KNN question. Now we'll look into the nearest centroid classifier. Nearest centroid classifier is pretty simple. So looking at the question, looking at the theory here. So it is simple alternative to KNN. So it is also called as mean difference classifier. Idea is to classify a test instance to the class whose centroid or mean is closest to the instance. Here we made use of the Euclidean distance, right? We took, depending on the input, here it was given k is equal to 3. So we considered for the test instance, whichever are the 3 nearest k values, 3 nearest neighbor values were considered, and based on them, the instance was, the final class was predicted. Here we make use of centroid. Okay, so the algorithm says training data set T, distance matrix D, and the test instance small t. Output is to predict the class or category. So firstly we compute mean or centroid of each class, and then we calculate the Euclidean distance, and then we predict by choosing class with smaller distance. So it is similar to the previous questions which we have solved, previous algorithms, but then centroid need to be considered here. So here I have x, y and class. So class A or B I need to determine. The test instance given here is 6, 5. Okay, so I'll find out the centroid of A. So in order to find the centroid of A, I write 354. Okay, 354, comma, for B it is 7, 6. For B it is 7, 6 and 8, right? 7, 6 and 8. And 3, 5 and 4 on x side, and 1, 2 and 3 on y side. Here also 7, 6, 8 on x side, and 6, 7, 5 on the y side. Okay, so this is for x and this is for y. This is for x and this is for y. And I'll divide it by 3. Okay, so because 3 values are being considered on both the sides, right? So I get, if you solve the centroid for A would be 4, 2, and centroid for B would be 7, 6. So once I've calculated the centroid for A and B, I'll consider the test instance. Euclidean distance between 6, 5, that is the test instance, and 4, 2, that is centroid of A. If I find the Euclidean distance, I get 3.6, and Euclidean distance between the test instance and the centroid of B, of class B, I get 1.414. So I can say that 1.414 value is less, right? So the test instance has smallest distance to class B, so the T is predicted as class B. So this was about nearest centroid classifier. Now we'll look into the regression analysis. So regression analysis is a supervised learning method for predicting the continuous variables. So even in the first module we have discussed the definition. So the difference between classification and regression is that in regression we use to predict the qualitative variables, not unlike the categorical variables or labels. Okay, so it is used to predict linear or non-linear relationships among variables of given data set. So let us consider this equation: y is equal to f of x. So x is said to be the independent variable and y is said to be the dependent variable. So if you look at these graphs here, so this one is linear graph, straight line, and these are non-linear graphs. Okay, then moving next, we have types of regression methods. So regression method could be classified as linear, non-linear, and logical regression. Simple regression means like this equation: y is equal to f of x. And then multiple is you have multiple dependent values and one independent value. That's what multiple states. And then polynomial is you make use of a polynomial equation to solve it. Logical is you make use of, I don't know, it's logic, I guess. And coming to the limitations, we have outliners here. So outliners are the abnormal data. Because of this abnormal data, it pushes the regression line towards it. So that's what it is a drawback to the regression method. Then we have number of cases. So in order to get proper regression graph or the lines, the ratio of the independent to dependent variables should be at least 20:1. Okay. Then we have the missing data here. So because of the data being missing, the model could be unfit. And then collinearity. And then this collinear problem, so it could lead to vulnerable bias. So this was about regression analysis, basic introduction. We'll look into the linear regression topic. So one question or one numerical or the explanation could be asked from this topic. Okay. So in simplest form, linear regression model can be created by fitting a line among scattered data points. So this is the equation of linear regression: y is equal to a0 plus a1x plus e, where a0 is the intercept which represents the bias, a1 is the slope, and e is the error in the prediction. These are called as the regression coefficients. So the idea of linear regression is based on OLS approach. So this method is known as ordinary least square method. So in this method, the data points are labeled using straight line. Any arbitrary drawn line is not optimal line. So 3 data points and 3 errors, E1, E2, E3. The vector, the vertical distance between each point and line is called as error. So these individual errors are added to compute total error. E1, E2, E3 are the errors. Okay. So writing the equations for different lines, for y1 line, I would get y1 is equal to a0 plus a1x, a1 x1 plus e1. And for n number of lines, in general, I can write yn is equal to a0 plus a1 into xn plus e of n. In general, error can be written as this error, you send it that side, so it will be e of I is equal to yi minus a0 plus a1 xi. So a regression line is the line of best fit for which the sum of squares of residuals is minimum. Okay, so the minimization can be done as minimization of individual error by finding parameters of a0 and a1. So this is the main formula to remember, because based on this only we have numericals. These are all the theoretical part. So consider this example. The x values are given, y values are given. We need to find the a0 and a1 value. We need to compute the equation, okay, the linear regression equation for it. So here sum of xi would be 15, average of it would be x bar, that is 3. Sum of y is 12.6, average of it would be 2.52. Okay, now that I've calculated these, I'll calculate xi square into and xi into yi. So find xi square and find the summation, find xi yi and find the summation. So after finding xi square summation, the average, I got 11, and after finding xi yi average, I got 8.58. Now I need to compute the slope and intercept. The slope is a1, we have seen here, right? A1 is the slope, a0 is the intercept. A1 is the slope. The formula is xy bar minus x bar y bar. Xy bar value we know, that is 8.58, so I wrote it 8.88 it is. Okay. Next, x bar value I have calculated here, it is 3. Here it is 3. And then y bar value also I know it is 2.52 here, so I'll substitute it here. Xi minus xi bar whole square. Xi bar whole square value is 11, so I wrote 11 here. Minus x bar whole square. X bar value is 3, whole square of it would be 3 square. I find a1 value. Similarly for a0, the formula is y bar minus a1 x bar. So after finding a1 value, I'll substitute it here along with y bar value and x bar value. So I find 0.54. Once I have found these points, I will write the equation. Okay, the equation would be 0.66x plus 0.54. So here they have given for first week, second week, third week, fourth week and fifth week. Using these I can compute a line. Okay, the linear regression line is I have obtained the graph. Now in the question they have asked for 7th week and 12th week. So with this equation it is easy to predict. Just I have to change the value of x here. So when I substituted the value of x to be 7 and 12 here, I got 5.16 and 8.46 values respectively. So these are the answers for these are the predictions which I'm able to perform. Okay, so that is about the linear regression and regression analysis. Next we have the linear regression in matrix form. This question is slightly tricky. I would say if you get this, look into the optional part. Anyways, I'll upload this in the notes. You can have a look at it. Next, we have a validation of regression methods. This is important because it could be asked for 4 marks or 5 marks. So firstly, we have the standard error. Standard error is the regression model should be evaluated using some metric for checking the correctness. So residuals or errors is the difference between the actual y and the predicted value y cap. Okay. Then we have the mean absolute error. For mean absolute error, the formula is 1 by n, summation of I is equal to 0 to n minus 1. We have yi minus yi cap in mod. Okay. Then we have mean square error. This was mean absolute error, right? This was mean square error. Square of this would give us mean square error. Then we have root mean square error. So this is square root of MSE. Okay. Then we have the relative mean square error. This is RE MSE. So ratio of prediction of ability of y cap to the average of trivial population. The value of 0 indicates that model is perfect and its value ranges between 1 and 0 and 1. If the value is greater than 1, then created model is not a good one. Okay. So here I write yi minus y cap whole square by yi minus y bar whole square. Y bar value is predicted value which we have seen here. So once we solve the problems, we'll understand it better. Then I have the coefficient of variation. So it is root mean square error by y bar value. Okay. So consider this question. The following data set is given. Okay. So this is the items. Actual values are given here. Now for I6 and I7, actual values are 80 and 75. I6 and I7 actual values are 80 and 75. I've written it. A regression model predicts values of I6 and I7 to be 75 and 85. So the predicted values are 75 and 85. So we need to find all the errors. Okay. We have 5-6 errors here, right? We need to find all the errors. First one, the mean absolute error. Mean absolute error, the formula is this, yi minus yi whole cap. Yi cap, I know the value here is 80 minus 75 and plus 75 minus 85. I get 7.5. Now mean square method, mean square error, square of this. Okay, square of each terms firstly. So 80 minus 75 5 whole square is 25 and 10 whole minus 10 whole square is 100. So add these and divide by 2, I get 62.5. Then I have for root mean square method, I have under root of mean square error, right? So I get 7.91. Then for for relative mean square error, I have yi minus y cap whole square. Y cap value, I have known it from the question, right? But y bar value, I don't know. In order to calculate the y bar value, I'll add 80 plus 90 plus 110 plus 100 plus 120 and divide it by 5. I get y bar value. So 80 minus 75 plus 75 minus 85 by 80 minus 100, that is y cap, y bar, and 75 minus y bar, again 100. So if you solve this, you get 0.1220. Now coming to the coefficient of variation, I have root mean square error by y bar. Y bar value I have calculated here, it is 100, and here the value is 7.91 I have obtained. Divide these two, you get 0.8 approx. So this is the answer for coefficient of variation. So I would say that the third module topics are slightly tricky, but then if you practice these questions, if you're thorough with it, it will be easy to score marks. So I have tried covering most of the important topics of third module. Do refer my notes. I'll upload the notes also. The link, the Google Drive link would be available in the description and in the comments. Do subscribe to my channel. If you have any doubts, do let me know. And I'll be uploading the other modules also. Stay tuned. Thank you.